group quiz, your meeting quiz, Chris? Oh.
So you'll just have
I
to write
had
it
it on
down.
the computer, and then the internet went down again, and so I was starting to do it, but I had it open. So no, I'm just sitting on the car. I'm just going to be kind of here. Does that make sense?
That's right.
Ah!
When I first started school, I would take my kids to McDonald's and use their Wi-Fi.
Uh,
Like let them play while I did homework or something.
it was a win-win. Seriously.
Yes, that is seriously a win-win.
Totally.
If
Totally.
it doesn't correct itself, I may end up going to racetrack because I don't have like the SPSS loaded on my work computer.
Oh.
I mean, I can access and do the quiz from my work computer, but I can't do the SPSS because I can't load that on my work computer.
Oh,
Okay,
gee.
so Stacy, you're gonna laugh at me. I didn't buy the SPSS until right before the test.
Oh, really?
Seriously. And then, so we have a password on our like administrative, like my husband's done it on purpose. And so he was okay. I seriously missed the Pinewood Derby last night to do homework and take this test. And I'm like sending him messages going, I told you I had to download this. What's the password you were supposed to get?
Oh, how funny.
It was a super
And they only
hard
asked you what? Yeah, they asked you like what, 3 questions?
I know, and I was like, seriously, I paid what was it, $40 or whatever for this?
Right.
Yeah.
Right. Oh, that's so funny.
Well, I can't even download it on mine because of the firewall at school.
Oh, I bet. Because I have a work computer, and I was like, they probably wouldn't be happy. I probably don't have administrative rights for that kind of stuff.
Yeah. That's hilarious. All right, well, let's get going on this thing because it's so exciting.
Well,
yeah, but you know what? This is what our project is going to be based on. This is how we're going to have to set up our own project at the end of the year.
Well, and this is officially, in my opinion, why statistics have a bad name. Why? It's all like backward thinking.
Yes.
Yeah. Like it's null. So like just in our regular talking, we think that means nothing. Like, but that's what we're, it's one that we believe in.
Right. Right.
It's like having a double negative or something. And I'm like, what?
Right. Is it supposed to be a good thing or a bad thing?
Yeah.
Well, it's null and void.
Right. See, like null.
Exactly. All right. Well, did you guys have any questions on part 1? It was more just.
No, it was just kind of filling in the blanks.
Yeah.
Yeah, because it's all new material. It's kind of like, and then of course more Greek letters.
Right. Why not?
That is like the hardest part. Going, what does this symbol mean again? What is this symbol?
Right.
Okay. The only question. The equation in real words, like this.
Right.
X minus mu over what? No, I have to write it out.
Yeah. Exactly. The one question on part 1 that I had, it was like, think of a couple examples where you've seen hypothesis testing in real life. I was like, I don't know. I mean, I've been a house mom for 18 years. I don't.
You have not for 18 years.
I have.
You have an 18-year-old?
Wow.
She will be in September. Yeah.
You did not look like you have someone that old.
Well, thank you.
Well, that's like, this is totally. So my sister and I were talking. One of my sisters and I were talking about the Chinese New Year, and she goes, "Oh, it's the rooster." And I go, "I think I have a rooster." She goes, "Well, it's every 12 years. Do you have a 12-year-old?" And I'm like, "Yes, she'll be 12 this year." And she's like, "Holy smokes!" See, it happens.
I know. It does. Well, I told my daughter, "My gosh, you're graduating. I still feel like I'm 20. How do I have a senior that's gonna leave, and I'm still a senior?"
See, I do feel that way. I just buy a pair of Converse, and my son goes, "Mommy, those look like teenage shoes," and I'm like, "I love
it." That's so funny.
Oh well, I'm way past that.
That's right.
You're only as old as you feel, right, Chris?
Some days I feel 200. Yesterday I felt 200.
Oh yes, I get it. Funny. Well, Eduardo, we see your little picture there without a picture.
Yeah. How are you guys?
Are you here?
Yeah.
Good. How are you doing?
Hello.
Hey, well, a couple of one of those things about a couple of examples. Is a normal blood pressure really 120/80?
That's true because the body temperature is not true.
Right.
That's right.
Which is so
That's
crazy
right.
because they preach that
What I
like
feel
everywhere.
about the income is the
What was that?
entry levels what they say it is.
That's
Yeah.
a good point too.
Yeah.
Don't
Yeah.
ask me to prove it.
That's
I would have no idea. Like, well, yeah, you go collect a bunch of, find out what people are making.
Yeah, exactly.
Let's stick with Skittles.
That's right. Skittles sounds good. All right. Well, let's start. So, question 9, part 2, question 9. The Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration programs. Scores on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple years. So on A, they want us to determine the null and the alternative hypothesis.
Well, the null is the mean is equal to 529. That's the null. That's what's there.
That is our positive, double positive, right, Carrie? Not our double negative.
Yep.
Yeah. So then
We're on part 2 of the preparation assignment.
Okay, good. Okay.
9A.
So the null hypothesis is the 529, and then because it says improved, we would do the greater than.
Right.
Yeah, that's our alternative.
That's the alternative. Yeah.
The mean is greater than 529. Yeah. Okay.
Once again, make sure you read it correctly to pull out the information.
Right. All right. B, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the students taking the exam is still 529. Was a type 1 or type 2 error committed?
It's type 1.
Okay, Carrie?
I don't remember reading about different types, so
yeah, but anytime you reject the null, it's a type 1.
Oh.
So, well, anytime you reject the null and it's actually true,
right,
is a type 1.
Type 1.
Yeah. And anytime you failed to reject the null, but it was actually false, is a type 2 error.
Well, but see, they kind of use that because you're not, see, this is where like that double negative, you're not proving it's true, you're just not proving it's wrong.
Right.
Right.
Because I think the reason they leave it open like that is because there's always new data and new thought processes, you know? That's the only way I could think of it, of why they would word it that way.
Well, and because they can't ever really come up with solid evidence, they have to say, well, we didn't fail to prove it wrong, so we're going to keep it the same.
Well, kind of like the cell theory. Like what was taught in high school when I was in high school is completely different than what is now taught in anatomy. And it's because they weren't done. I mean, they're constantly learning in new things.
Right. Like Pluto's not a planet anymore. Hi, buddy.
That's right. It's a moon.
All right.
That's a conspiracy theory.
Okay. So C, if the analysis was done at the, okay, I forgot the word for it. I got alpha, but
alpha.
Yeah, alpha 0.01 level. What is the probability of committing a type 1 error? So I'm trying to remember the name of that word. This is our level of significance.
Well, that to be 1%. You just move that decimal over.
Yeah.
It's time for my class now. It's after 9, go to bed.
Yeah, because the other term, the other term for the level of significance is the probability of type 1. So you just take that 0.01 and put it into percent, which is 1% or 1 out of 100. All right. D, if we wanted to increase the probability of making a type 2 error,
Now you want
we
to
would need,
increase the probability.
sorry, yes, if we wanted to decrease the probability of making a type 2 error, we would need to increase or decrease the level of significance.
Need to increase it.
Yeah.
To have the opposite effect.
Yeah, they're directly related. So if one increases, one decreases, vice versa. All right. Did you get all that, Eduardo?
Did we lose him?
I think
I have
so.
no idea. Are you still there, Eduardo? Somebody's there. All right, well, let's keep going. A study by the National Association of Realtors reported in 2004 that the second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment properties in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and obtains the value. And I'm not going to read off all those numbers. So, A, design the study. What is the population from which the realtor obtains his data?
Well, the
How did he sample?
thing. So that's
Oh,
second home buyers.
okay.
Because it's not a sample. His sample is just 15, but the population is second home buyers.
Yeah.
Mm-hmm.
And then, let's see, how did he sample this population and what is the research question?
Well, it was some sort of report.
Yeah. I just put that he put down a simple random sample from his clientele.
Yeah, that's what I put.
And then
His question is the age of people buying a second home lower in my area, in my neighborhood? Is it different?
different.
I'm sure he had
Yeah.
advised.
Different would be probably.
Yeah, different is the key word there. So on B, we collect the data. Name at least one way the realtor could have randomly selected his sample.
Well, put a names in a hat.
Yeah, he could. One thing I think he could have done better to make it a better, because he only had 15, which isn't a large sample, is he could have actually asked different real estate companies in the area to give him
Like
whatever X
15
number.
from like 15 different companies.
Yeah.
That's a good point. Because the law of, large numbers.
Yeah. Yep. And the central limit theorem as well would make it a little easier. But he would have had a more accurate understanding of the situation if he had done that. So I said, I don't know if that's what they wanted because they didn't tell you, but I just said it would have been better for a stratified random sample if he had done that. But
I think the whole point is to get us thinking and talking. I don't think there's probably a right answer or wrong.
No.
Maybe something better than it.
Yeah. Okay. C, describe the data. Graph the data on a histogram. And now that you've got your SSPS, you can do that. Sketch the history. Sketch the histogram.
Put all those ages in there.
Like, because it's not like a file I can open, right? Honestly, I don't know how to open it without like opening a document in BYU.
Yeah.
Just open it and it comes to a blank file and you can put all those in.
You just put all the variables in that first column and then you go and ask it to plot this graph or pull up this statistics or I could show you. Here, I'll show you. Let me pull up the screen. Let me find it first. Okay, here's. All right, let me pull up the screen of what I ended up doing. It doesn't want to give me. Let me pull it. All right, let me do this. Okay. Trying to find you guys again. Okay, so this is what I ended up doing with all those numbers. I just took all the numbers and put them down that column. And then I went over to analyze Well, they wanted a graph first, so to legacy dialogues down to histogram. Let me go pull that one up. Let's see. Sorry, I have to switch back and forth.
As long as you keep talking.
That's right. Okay, so here I'm up with that, those numbers. What are we supposed to do? In a short paragraph, describe the data by using at least 5 descriptive statistics. Now they want us to use our statistics lingo.
Oh, yeah.
So, Carrie?
Well, it definitely looks like it's skewed to the left. A little bit. It doesn't look, and that might also lead back to what both of you pointed out, that he doesn't have a very large sample in the first place.
Yeah.
And like you said, 15 wasn't.
Right. If he had gotten more, it may have turned out more bell-shaped.
Right.
Eventually.
The minimum was 27.
Yeah. Yeah, the minimum was 27. Maximum was about 58. If you look up in the right corner, it gives us the mean of 46.73 of those numbers and the standard deviation, as well as the value, how many he asked. So, okay. I don't know if we have to go back to this. And then we're supposed to make an inference. Oh, and I just said on it, because there wasn't a large enough sample, then the central limit theorem doesn't apply, and doesn't appear to be normal distribution right now.
Well, and even if you run a QQ plot, they don't all line up.
Yeah.
You can make a QQ plot from that SPSS.
Oh yeah, let me pull that QQ plot up, because that was another thing. There it is.
See how off limit there's some off on the side.
Yeah, so they're all they start here, and then they curve down and curve back up and curve down and back up. So
I think the whole point is for us to kind of like, we're at the stage now that we're taking a chunk of data and using and talking like what we've been learning about, like all of us have just said, it's not a very large sample. It's not evenly distributed, like they want, I think that was the whole point, that they want us talking like that.
Yeah, they're trying to help us understand.
One of the other things they're doing is they're looking at this is what you're going to do for the final project. You're going to have to go through all of these steps.
Put all the variables in, and
well, I want my money's worth of SPSS, so yeah, let's do that.
That's right. Okay, so on D, they want us to make an inference. So they said check the requirements. Since there's only 50 pieces of data, what will you need to check? And so if you go to what they asked for requirements, it says, assuming the data, we have to assume the data represents a simple random sample from a large population. Well, definitely got a simple random sample. And then we had to assume that it was, if it's drawn from a population that has a normal distribution, either the population is normal or the sample size is large. And that's the one thing I said, is it's not normal because the size wasn't large enough.
Right.
And then they also said that the standard deviation is assumed to be known, or some of the requirements, which we are given it up in the description. So, all right. So if we go back, okay, I don't know if we need this, so I'm going to unshare it for now. It's D number 2, state the null and the alternative hypothesis.
Well, the null is the mean is equal to 47.
Yep. And then Carrie, do you know what the alternative hypothesis is?
Well, I could say that it's larger.
But you have to put it at not equal to.
Oh, not equal to. Well, don't we have the choice of not equal to, or larger or smaller?
Well, what we have is different, so not, which makes it not equal to, and then you have less than or greater than. But if you look up in the description up above,
we probably don't have enough.
Well, he wanted to know, he said the average age of those buying investment property property in his area is different than the national average. So that's what he wanted to know, is if it was different. So the alternative would be the mean is not equal to 47. So we want to know, we're saying on either side, whether it's less than or greater than. He said that's what he wants to find out.
So we're comparing it to the national average.
Correct.
So either our null is it does match it, or it does not. Oh, okay.
Yeah.
So we don't really have enough information to go.
Yeah. So far, so the alternative, the hypothesis he's trying to prove is that it's different somehow, either greater or less than. So on 3, it says let the alpha, or the level of significance, be 0.05. And so then on 4, it says compute the test statistic, which we know is called the z-score. So they just gave it a different name for us. And then we use the formula that we were using before, which is the sample mean minus the population mean, or the null in this circumstance. And then we take standard deviation divided by the value. So that's, if we looked at the mean of the graphs that we were looking at, it was 46.73. And we minus that by 47, or we minus 47 from that. Divide that by 5, the standard deviation, which is 5 divided by the square root of 15. So I got, well, actually, what's funny is I got 0.209, and I went back and checked my answer 5 million times, but they had answer of negative 0.207. So I used that for my z-score, because obviously they're always right.
Yeah.
You got that?
I got the 9.
Okay. You got the 9 too? I did too. I did it like 3 or 4 times. So anyway, we get the idea. You just get the z-score how we're supposed to. But so then on 5 it says, or yeah, number whatever, D5 it says compute the p-value. So first sketch a standard normal curve, graph your test statistic along the horizontal axis. So they wanted just to sketch one by hand with that z-score of 0.207, right? Which would actually, so the mean is 0 right in the middle. So 0.2 is not too far from that mean. And so, here's the thing is we want it on, because we want to know if it's different, we want to highlight the left and the right of that z-score.
The greater and then less than kind of thing.
Yeah.
But you don't want it in between. You want just the 2 tails.
Yeah, the 2 tails. Yeah.
That's a good way to think. So what z-score did you get?
It was 0.207. Even though I really got 0.209, but both Chris and I did, but who cares? We'll just. So
are you getting a probability of 0.8360?
That's it. Yeah. So when you write that down, then you compare it. So you put the p-value and decide whether it's greater than or lesser than the alpha, which is 0.05. And 0.836 is a lot bigger than 0.05. So because the probability is large, then on 6 we
reject the null.
We failed to reject it.
Failed to reject the null.
Yeah.
If the p-value is low, you reject the null.
Oh, because he thinks it's different.
Yeah.
See, it's this whole negative.
I know. I have to keep looking back at my notes to say, wait, am I rejecting or am I keeping? Because it's hard to keep track. And then it said, state your conclusion in terms of the alternative hypothesis, which is, what'd you put down for?
Evidence to support it.
Yeah, there's insufficient evidence because the p-value is greater. We failed to reject the hypothesis. And they want us to use, real lingo. So they put down something like, not enough evidence. We failed to reject the null hypothesis that the mean of the people buying a second home is different than that of the national average. Okay, so just a lot of jargon. And then E for that question is, what action, if any, do you suggest the realtor to take based on your statistical conclusions?
Get a bigger sample.
Well, what we've already said, like if he really was truly after this information, he would have a bigger sample.
Yeah.
Yeah, but he also needs to be watching it too, because prices in his neighborhood his neighborhood may change. All of a sudden he'll get a bunch of older people who are investors.
Yeah.
Mm-hmm.
Yeah. But according to the information that we got from our probability, what they said is, hey, keep focusing yourselves on your middle-aged clients, buyers, because they're the ones that are buying them. So, anyway.
Isn't it weird how like it falls back into like the philosophy and thing, like.
Right.
Yeah.
You know what I mean? Like their statements are like fallacies.
Right.
Like, let me scientifically prove your statement is stupid.
This reminds me a lot of geometry. I hated geometry for that reason. Prove the theorem is right, and I'm going, because it's there.
Because you told me to.
Right.
Yeah.
Right. All right, you guys ready to try the quiz? Have fun with the quiz?
Let's do it.
All right.
Oh, I thought we lost you.
No, I'm here.
He was listening. It's just that we girls talk a lot more than guys do.
Oh, yeah.
And I get off topic, sorry.
No, it's good.
I need adult conversation.
We're desperate, Eduardo.
Oh,
yeah. All right.
So lesson 9 group meeting quiz. Let's do this.
Make sure you answer 1 and 2.
Oh my gosh, it's huge.
It is? Oh, shoot.
Like 30 something.
It's almost as big as our test.
Yeah, but
question.
What do you guys think of that test?
How did you do?
I did okay.
That's how I feel.
But the thing what sucked is so I was done within like an hour and a half, and my internet went out.
Oh,
I was saving all my questions and everything, and then all of a sudden my computer just closed my internet, like my actual browser, and when I went back into iLearn, and it didn't save any of my questions, so I had to redo the exam again.
Oh.
Yeah, it was so frustrating.
Yeah, at least it let you back in.
Oh yeah, for sure.
Yeah. I could have done better, but
Hey, she is passing.
Yes.
Yeah. Hey, she got good.
Oh, you're so sweet. You only missed 1. I missed 3.5.
Yeah, but think about that. That's really not that far. It's just that they put them on. I was like, why are you making these worth so much points? You're making me mad.
See, I agree. Like, why? I think that's horrible. And then you're like, so I missed 1 and I got a D. Thanks. Like, I don't think that's really fair to test me on my knowledge.
That's right. Oh, all right. Question 3. Are you guys there? You ready?
Yes, ma'am.
Chris, you writing yours down?
I'm writing it down because I'm sitting in my car. Yeah, so I'm working.
Okay. Okay. So this question 3 says, which hypothesis, either the null or alternative, involves equality? So
isn't that the null?
That's the
yes.
Null.
Yeah. Yep. Yes, we got that one right. Woo. All right. The p-value is the property of obtaining a sample statistic at least extreme as the one that was actually observed. Use this information to answer the next questions. Question 4. Remember that the p-value is the probability of obtaining a sample statistic. Okay, we just read that. When computing the p-value, which hypothesis do you assume to be true, null or alternative?
The null, right?
No.
Yep. Agree.
Oh, I thought Chris said no, and I'm like, okay, then I'm lost.
Yeah.
No, she didn't say null. She said null. It's that double negative thing. It's always getting us.
Yes.
Okay. All right. Suppose the null hypothesis is the mean equals 10. Use this information to answer the next questions. Which of
It's
the following...
3 questions.
Oh, sorry. Which of the following represents the alternative hypothesis for a two-tailed test?
Two-tailed would be the not equal to, isn't it?
Yep, correct. So the third choice, mean is not equal to 10.
We're on a roll, guys.
Don't jinx us.
Man, I like this quiz so far. All right, which of the following represents the alternative hypothesis for a left-tailed test?
Less than.
No, less than.
Yeah,
So think of where the tail's pointing.
mean is less than, so that would be the first one. Then 10. Okay, who wants to take number 7?
I'm going to go on a limb and say it's the greater than.
Okay.
You're reading the question.
That's right. Which of the following represents the right-tailed test? All right. Yep, greater than. Which is the second. Okay. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information. All right. So question 8. Which relationship would result in failing to reject the null hypothesis?
That would be...
Go ahead, Chris.
That's the probability is greater than...
Yeah.
Greater
We just
than,
did... Yeah, greater than alpha. We just did that one on our whatever it's called, part 2. So that would be the first choice. P-value, right?
Yeah.
Sometime. Okay. All right. Question 9. Which relationship would result in rejecting the null hypothesis? And that would be p-value is less than alpha.
less than.
Yeah.
See,
If
once
P is
again,
small,
the difference between rejecting and failing.
That's right.
no, well,
Because
we
in our
never
English
fail.
class, or language arts classes, they would mean the same thing.
Right.
Yeah.
Only in math would English
Never
not mean
fail.
English.
Only reject it.
That's right. All right. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was $1,500. They're concerned that the true mean is actually higher. So there's our keyword. Use this information for the next questions. Which of the following would be an appropriate hypothesis? So 1, the average claim is equal to 1,500. B, the average claim amount is not equal to 1,500. The average claim amount is greater than 1,500, or the average claim amount is less than 1,500.
Well, because the verbiage uses the word actually high, they feel it's actually higher. I want to lean toward that, but aren't we supposed, isn't the first line of defense kind of, it's just not equal to?
Only if you want to find a difference, so which could be either greater or lesser. And this one, I think your first response, I think, is correct. What do you think, guys? Think, Eduardo and Chris? Where they said they want to find it higher. Sorry, go again.
When it says higher, I think it's got to go greater than.
Okay.
Yeah, I agree.
Once again, following the verbiage.
All right, what do you think, Eduardo?
10, right?
We're on 10, yeah.
Okay, yeah. I think it's greater than, yeah.
Okay. All right, question 11. Which of the following would be the appropriate null hypothesis? Yeah, which one do you think it is, Eduardo?
For me, let's see.
Is it the null or the alternative?
It's a
Null.
It's the null, okay.
Wouldn't it be less than 1,500?
No, the null is always that.
Oh no,
our
it's greater.
standards.
It'd be greater than, right?
No,
No.
the alternative is greater.
Yeah, the alternative.
The null is going to be equal to 1,500.
Oh, okay.
Yeah. So the null is always going to be equal. It will always have that equal sign no matter what. And then the alternative will either be not equal, greater, or lesser. And so, all right. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Use this information for the next 3 answers. All right, I'm going to write those numbers down so I don't have to keep going back up and looking at it. Okay, and this is for the same. So our population mean was 1,500, right? That was our null.
Right.
And then our sample mean is 1,650. Did they give us a deviation?
No, they did not.
Okay, just want to make sure. Okay, so question 12. The insurance company assumes that distribution of the sample mean is normal. Is this a good assumption? I would say looking at the n equals 40, that it's a good assumption because it's a large sample. So I would pick number 1. It's a good assumption since the sample size is large. But also, I'm going to go see what they say up there.
Well, I wouldn't use the verbiage normal versus not normal because statistics never uses that.
Yeah.
Because normal is subjective. So it's either it's a good assumption because it's large, or it's not a good assumption because the sample size is small.
Yeah. Well, and sometimes though, like in the description, they'll say this population was normally distributed.
Right.
And so I went back up and looked, and it didn't say anything about it. So I'm gonna, I'd say the sample size is large, a good assumption. So 1, the first answer. I almost said probability. And then
look, number 13.
Why don't you take that one, Carrie?
Central limit theorem.
All right, what theorem or law justifies your answers? The central limit theorem. Sorry, I'm reading it for Carrie because she's doing it blind here. Not Carrie,
sorry.
Chris. You're like, what?
Yeah. What?
Chris is like, what are you talking about?
It's our favorite theorem.
That's right.
No, I can figure these out.
Oh, I know you got this no
You
problem.
probably got 100% on your test, didn't you, Chris?
No, I didn't.
No, she got a 99.
No,
A 99.9%.
She forgot to write her name on it.
no.
Figure that out.
I got an 89. Yes.
What'd she say?
She got an 89. You guys were robbed.
Shush. I don't believe that. You kicked my butt in this class. Okay, so what is the following? Which of the following is a test statistic as defined in this lesson? Isn't that the z-score, but they now call it something else?
Yep, it's now called the test statistic.
Which is the S, right?
Why did they
Z.
It's still a Z?
Yeah. Yeah. So it's our z-score. It's just the z-score, but they're just going to give it a new name. That's unsophisticated to call it
Why do they have to mess with us?
All right, the historical mean of cells. You what, Chris?
I don't know why they keep changing names.
I know. I just get used to one and they change it on me.
It's rude.
Rude. The
Word.
historical. That's right. Now I'm going to have to change my flashcards. No, I don't have flashcards. It's okay. The historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. The store manager suspects that the average has decreased. So there's our alternative hypothesis. She sets up a hypothesis test with the hypothesis. The mean of 150. The null hypothesis of 150, its alternative is less than 150. Okay, so she will use a level of significance at 0.05. That's our alpha.
Uh-huh.
And then she takes a random sample of 36 sales receipts from her store and computes a sample mean of 144. Sorry, I'm just writing these down because I hate coming back up and looking at them.
I don't. So our sample means so it's 144 minus the 150, right?
Yeah, yeah.
Which would give us a negative right off the bat. And then it's standard deviation 40 divided by the square root of blah, blah, blah. What's our sample size? 36.
Yep.
6.
Yep. Okay, square root of 36.
I wish we could take our test like this. We would rock it.
I know. After all, we are leading each other astray. Why can't we do it on all of it?
I know we're teaching each other. Why not? So.
Okay. Isn't the square root of 36 6? I love it when it's even.
They only do that in the beginning.
Yeah.
I know.
Yeah.
Now it's a crazy number.
Yeah, then it gives us an ugly number.
Oh yeah.
Okay.
Like 6.6. No,
Did you guys get a
1.666
negative?
or something.
Yeah, it would be a negative number. All right. So I got a negative 0.900000. So it's negative 0.9. Whoa, except there's a 9 down there somewhere. Anyway, did anybody get something different?
I got that.
Okay. So 6 points.
So we have a probability area of 0.3681.
Hey, ask us.
Oh.
Yeah.
Oh, wait a minute. Do
So
I have
the
my tails the
Z-score-
right way? Sorry.
No, the z-score, they asked us to round it to 3 decimal places, but that negative 0.900, I kind of think, well, that's weird.
I think
Um,
that's what we have.
Let me just double check my math.
Doesn't that give us a very negative, very small number, like that says the E on it?
Probably.
No,
Let me.
I didn't get an E. Well, what way are we supposed to do the thing?
They wanted to know it's less than, so you do on the left tail of it. So let me go over.
But because we have a negative number, oh, it's 0.1841.
Yeah, that's what I got. P equals.
Wait, what'd you get?
0.1841, which is
184.
greater
Yeah.
than the alpha.
It is greater than alpha. Yeah.
So what
So
is
if
the answer?
Oh, well, it didn't
Oh,
ask us that part yet. So the first one is the 15 wants the z-score, which we all came up with a negative 0.900. And then 16 says, what is the p-value associated with the z-score from the previous question round? I thought the p-value was the z-score. Crap.
no, the
Or is
p-value is the probability.
Oh, so that's it. So now that has a new name too?
Well, sort of. I mean, they did use it at the beginning, and then they kind of went to probability, and now they're back to p-value.
Okay, and then we're doing rounding it to 3, so it's 0.184, right?
Yeah.
For
Then
16?
17 says, what inference would you make about the null hypothesis for this problem? So this is where
Carrie pointed out that it's no.
Failed
You
to
had it
reject
right.
it.
So
Yeah.
it's greater than the alpha, so that means we have to.
Failed to reject the hypothesis.
Yeah, we failed to reject it.
Which in my mind means the same thing, but no, they're different things. So, let's go back up. So earlier we said, okay, failing to reject means when the p-value is greater than alpha, or
Yeah.
the relationship when it's less than we reject it. So we're failing this bad boy, right?
Yep, it's failed.
Failed.
Yeah, we're failing to reject it.
Yeah.
Okay.
And then 18 says, what's your conclusion for this problem? So we failed to reject it, which means we have insufficient evidence
That
that the true population mean is less than 150, right?
right.
Uh,
Look at all these double negative. So it's 3, the third one down,
See-
right?
Yeah. Yeah, math likes double negatives because then it makes it positive.
Uh-huh.
See, okay. There are 2 types of errors that can be made when performing the hypothesis test. This is number 19. Which one involves rejecting the null hypothesis when the null hypothesis is true? Type 1 or type 2?
Type 1.
Yeah. Type 1.
Mm-hmm.
Okay. Question 20. A researcher decided that instead of using a level of significance of alpha 0.05, he will use alpha 0.01. Which of the following will be true? So A, oops, I just scrolled past it. The probability of type 1 error will increase. B, the probability of type 2 error will increase. C, the probability that the null hypothesis is true will decrease. And D, his experiment will be more scientifically valid.
It's type 2. The type 2 will increase.
Yeah, I agree. Because when you decrease, so this level of significance is also called the probability of type 1 error. And when you decrease the type 1 error, then your type 2 increases. The probability of your type 2 increases. So I would agree with Chris. All right.
Last one.
Last question. Say that again.
Last one, guys.
Yahoo! Okay, so if alpha is 0.05, compute the probability of committing a type 1 error. Round it to 2 decimal places. Well, to me, isn't it
Now
just
that one-
0.05?
I'm stumped on because I don't know if it ever told us how.
Well, it's
I'm with Chris.
the way
They
I'm
didn't
reading,
tell us that.
the way I'm reading this question is if you go back to the okay, so in our part 2 preparation, if you go back to question 9, letter C, it says, if the analysis was done at alpha 0.01 level, what is the probability of committing a type 1 error? And it was 1% or 1 over 100 or 0.01. So I would say 0.05. It's 5% chance.
5%.
That's, yeah. So they don't want us to put it in a percentage? Go ahead.
Let's just talk about influence.
Yeah. All right, I'm going to submit.
I have a question.
guys
What
ready?
was 17 and 18? Sorry.
Oh, too
number
late.
18 and 19.
Just kidding.
So we put down for 18, after failing to reject the null hypothesis, that we have insufficient evidence that the true population mean is less than 150. So it would be in the C position, the third one down.
We have sufficient or insufficient? Oh, yeah, we have insufficient.
Insufficient, yeah, because we failed to reject it. And then there are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis?
Type 1, right?
Type 1, yep. That's what we
Okay.
put down.
Cool. Thanks, guys.
All right, yep. All right, I'm going to submit this. Let's see what damage we did, right? We are just awesome. We just got 100%.
Woo!
On the first try even.
Yay!
Yay! Well
Good
done.
job. Though I have like no clue what we just did.
Well, seriously, what it is for me, it's trying to get all the new concepts and terms straight in my head. That's how I felt at the beginning of the last one. I was like, I don't understand anything.
Because it's a whole new way of thinking. We're thinking in like a double negative.
Right.
So in my
Yeah.
mind, as we're going over, I'm like, how does that work? Oh yeah, because we're not rejecting it. Like
Right. You're right. So very cool.
Yeah.